All right, so I know a lot of you all have missed the past several days for various things, and so I wanted to show you guys a video of how to solve a lot of these problems. These are problems that you're going to see on your exam coming up on Friday. Now, the ones on the back here, 4, 5, and 6, these guys, they might show up on the AP exam, but I will not be giving an exam over those. Just these first 3 are the ones that are going to be on limits. So I want to make sure that you know how to work these. So if you need to at any point, you can work these out, pause the video, practice them yourself, whatever you need to do to get up to speed. Number 1 says an ecosystem has an ecological efficiency of 10%. If the producer level provides 10,000 kilocalories of energy, how much energy does the secondary consumer level provide? First thing we probably need to do here is draw us an energy pyramid. We've got producers, primary consumers, and secondary consumers. This says the producer level provides 10,000 kilocalories of energy. 10,000 kilocalories of energy. We also know that it is operating at a 10% efficiency, and that's pretty standard, okay? So that means that of this, 10% can get passed on each time, okay? So 10,000, the next one is going to get 1,000. And then we're going to pass on 10% again, and that's going to give us 100 kilocalories for that top one. So 100 kilocalories are available to that secondary consumer in this scenario. Next, create a numbers pyramid for an organism for organisms in a simple food chain in a boreal forest ecosystem. The top predators are a pack of 5 wolves. We see that right here. Each wolf consumes 5,000 kilograms of food each year in the form of a moose weighing 500 kilograms each. Moose consume 15 times their body weight per year in young aspen, birch, and sugar maple trees, with the average tree weighing 50 kilograms. Okay, so we got a lot of biomass in here, and we have to figure that out and calculate it. It says the top predators are wolves, and there's 5 of them, and each wolf needs 5,000 kilograms of food. So 5 times 5,000 kilograms is going to tell us how much weight that the moose have to provide in biomass for the wolves to survive. So 5,000 times 5 is going to give us 25,000 kilograms. Okay, that's not how many moose there are, though. It's asking for the number of moose. So what we need to do is we need to figure out how much each moose weighs and divide that 25,000 by that. So moose weigh 500 kilograms each, so 500 kilograms. So 25,000 divided by 500, 25,000 divided by 500 gives us 50. So we know that there must be 50 moose to support those 5 wolves. Now, it'd be real tempting to just go 5, 50, 500, go by tens, but that's not really how it works in this scenario when we're looking at number of individuals. Lastly, I have to figure out how many young trees there are. And so first I need to calculate their biomass. I know that each moose is going to eat 15 times their body weight. So I'm going to have 15 times their body weight. There's 50 total moose. We just solved for that guy. And we also know that each moose weighs 500 pounds. So we need to multiply all these together. 15 times 50 times 500 equals 375,000 kilograms, okay, of young trees. Now, again, that's not our answer. We're actually looking for a number of young trees, not how much they weigh. We know that each one weighs 50 kilograms, so that number divided by 50 kilograms should give us our answer, and it did, 7,500 young trees. So again, 7,500 young trees provide enough energy for 50 moose. 50 moose provide enough energy for 5 wolves in this ecosystem. Last one, down here at the bottom. Gross primary productivity in a region of tropical forest is 1,200 kilocalories per meter squared per year. In this ecosystem, producers are 25% efficient. Calculate the energy in calories, that's interesting because this is all in kilocalories, that is available to secondary consumers from 1 meter squared of forest over a year's period. Okay, so we know this is our food pyramid here. We got producers, primary consumers, and secondary consumers. I'm trying to figure this number out, but I got to figure out the rest of this. Now, we see words like gross primary productivity being thrown around, and that's interesting. We need to take that into note. Gross primary productivity is how much the producer will produce first, okay? But that's not how much it will actually pass on. That's the net primary productivity, which is gross primary productivity minus cellular respiration, okay? So gross primary productivity here is 1,200. Cellular respiration, it says that these guys are 25% efficient, so that means that 75% is taken away through cellular respiration. 1200 minus 75% is going to end up giving us 300 kilocalories. Okay, so there are 300 kilocalories available to be passed on here in the producer level. Now we also know that they are 10% every time that we go on. So 300, 10% of that would be 30 kilocalories, and then 30 kilocalories would be 3 kilocalories. Okay, I'm not done though. The problem asks us to figure it out in calories. So I have 3 kilocalories, needs to be converted into calories. I know that a kilo is 1,000. So 1 kilo is equal to 1,000 calories. All right, so 3 times 1,000 would be 3,000 calories that are available to the secondary consumers in this scenario. I hope this helps.